Use proper measurement techniques. Tools and equipment. Use the correct measuring tools based on what you are assessing, example calipers for precision measurements, rulers for length, weighing scales for weight, etc. Accuracy and consistency. Ensure the tools are calibrated correctly and consistently used to maintain accuracy. Misuse or inaccurate tools could lead to incorrect measurements, resulting in potential quality issues later. Verify against standards. Compare the measured values against the workplace's predefined acceptable ranges or specifications for materials and products. If your company works with tight tolerances, even small deviations could be important. Workplace procedures. Follow any specific procedures laid out by your company for measuring items. For example, some workplaces may have a set method for how to handle a material during measurement to prevent damage, or a process for documenting the results. Example: if you're working with custom-made parts that need to fit together, measure each part's dimensions using precise instruments, ensuring they fall within the acceptable range. If the part should be 50 mm wide, make sure it's exactly or slightly under that size, no larger, as this could prevent the parts from fitting together. 2.3 Identifying and correcting actions. In this step, the focus is on identifying any discrepancies in the quality of the received materials or finished products and correcting them as necessary. If the received goods or products do not meet specifications, you must take corrective actions following established procedures. Identify discrepancies. Look for defects or quality issues. During the inspection and measurement process, look for deviations such as defects, damages, missing items, or incorrect quantities. Root cause analysis. If discrepancies are found, consider what caused the issue, whether it's from the supplier, example incorrect materials sent, an internal error, example incorrect handling or measurement, or a flaw in the production process. Take corrective actions. Rejection or return. If an item is found to be defective or not up to standard, follow company procedures for returning or rejecting it. This could involve notifying the supplier, issuing a return, or even refusing the delivery. Fixing defects. If minor defects are found in materials or products, decide whether it's feasible to fix them. For instance, if a part is slightly out of tolerance but can be adjusted, you may be able to correct it in-house. Rework or reprocessing. If parts or materials cannot be used in their current form, follow procedures to rework or send them back for reprocessing. Follow procedures for corrective actions. Most workplaces have specific protocols for dealing with quality deviations. This could include filling out quality assurance forms, issuing defect reports, and involving other departments such as the production or quality control team for further investigation. Example: if you receive a batch of fabric for garment manufacturing, and it's supposed to be 100% cotton but contains polyester, based on testing or measurement, corrective actions would involve notifying the supplier and rejecting the fabric, reporting the issue internally to adjust the production process, if necessary, documenting the incident to ensure future orders meet quality standards. Summary of key points. Checking materials ensures that incoming materials and finished products meet the company's quality standards and specifications. Measuring materials ensures accuracy in dimensions, weight, and other essential specifications, using the proper tools and methods. Identifying discrepancies and corrective actions involves spotting quality issues and following the right procedures to correct or return faulty products to maintain quality. Level 3, Record information. In this learning outcome, the focus is on documenting and maintaining records related to the quality performance of materials, products, and processes. These records are essential for tracking quality, ensuring compliance with workplace standards, and providing valuable data for audits or process improvements. 3.1 Recording basic information in the quality performance. This section highlights the importance of accurately documenting key details about the quality performance of materials, products, and processes. Effective record keeping helps track product quality over time and ensures transparency in the quality control process. Here's how to approach this. Document essential details. Product or material identification. Record the specific product or material being assessed, including relevant identification numbers, batch numbers, or descriptions. Inspection and test results. Document the results of any inspections, tests, or measurements performed on materials, products, or processes. For example, if you tested the weight of a batch of products, record the results and compare them to the acceptable range. Time and date. Note when the inspection was carried out. This helps to identify trends or patterns over time and ensure that inspections are happening as scheduled. Quality observations. Any notable observations about quality should be recorded, such as defects, deviations, or potential concerns that were identified during inspections. Action taken. If any corrective action was taken, such as rejecting defective items or fixing an issue, this should be documented, along with details of the actions performed. Clear and accurate recording. The information should be recorded in a manner that is easy to understand. Use standardized forms or templates, such as inspection checklists or quality performance logs. To ensure consistency. Avoid vague descriptions. Be as specific as possible in recording information about the quality of materials, products, or processes. For future reference or audits. Quality records serve as valuable references for future analysis or audits. Whether for internal process improvements, regulatory compliance, or customer quality assurance, clear documentation ensures transparency and accountability. Example. For a batch of products, you might record product ID, XYZ123. Test results, weight 100 g, acceptable range, 98-102 g. Quality observations, minor scratch on one item, reject and replace. Action taken, one item rejected and returned for rework. 3.2 Maintaining records of work quality. Once the basic quality information is recorded, it's important to maintain these records in an organized, up-to-date manner. This ensures that they remain useful for ongoing analysis, decision-making, or audits. Here's how to manage your quality records effectively. Keep accurate and up-to-date records. Ensure that records are consistently updated after every inspection, test, or quality check. Delays in recording can lead to gaps in documentation, which may impact the reliability of the records. Regular review. Check the records regularly to ensure they are current. If there are any discrepancies or missing information, take the necessary steps to update or correct them. Systematic organization. Develop a system to organize records, example filing systems, digital databases, or software tools. Group records by product type, date, or batch number to facilitate easy access and review. Tracking the quality of work, products, and processes. Keep track of how products or processes are performing over time. For example, if you're maintaining records on a particular production line, monitor consistency in quality and whether issues are recurring. Include metrics such as defect rates, rework levels, customer complaints, or performance trends. These records are vital for identifying improvement opportunities. Easy accessibility for analysis or reporting. Ensure that records are easy to access when needed for analysis, reporting, or decision-making. A good record-keeping system allows you to pull up relevant data quickly when analyzing trends or preparing reports for management or audits. Digital or manual records. Whether your records are kept in paper format or electronically, make sure the data is organized and readily accessible. Digital records often make searching and analysis easier and more efficient. Example. If you're tracking defects across a production line, record all relevant information for each defect, example type of defect, affected